Everybody, hello. Of course, if you don't know who I am, I'm the guy who's been talking with Liz for about the past 20 minutes. But otherwise, here's a little bit about me. My name is Josh Ludeman. I'm a senior data platform consultant and trainer at Pragmatic Works. I predominantly work in on-premise and cloud data solutions, but in Microsoft specifically. Though I do have experience with Oracle, Teradata. I also do a lot of work with our Hadoop practice and a lot of our Azure architecture work that we do. Been a tech editor before on a big data book that actually was written by our president of consulting, Adam Jorgensen, as well. Also a speaker at PASS Summit and multiple SQL Saturdays. So a little bit about what we're going to talk about today. We're going to obviously go through some of the performance improvements that have come with SQL Server 2016. But we're going to talk about some of the BI enhancements. We're not just going to talk about engine. And then we're going to do an overview of like what I call the big three. These are the big three performance or new features that are going to help performance in SQL Server 2016 in your environment. So you notice at the end I have Query Store, and some people are going, well, what do you mean Query Store is going to help performance? Well, we'll get into it a little bit more, but it's more of a window to help you improve performance, whereas the other two are definitely just immediate performance improvements. So when we talk about some of the general engine performance, there's a few different things going on that we're going, that you want to know about that aren't necessarily as big publicized, but they're actually very nice improvements. So, for instance, with your overnight or off-hours maintenance jobs where you're using DBCC, DBCC is actually, they've gotten into the code of it and actually improved the code so that it actually scales up to 7 times better. They've also gone through with it, and before, if you had any filtered indexes, user-defined UDT columns, or persisted computed columns, those, when you would run dbcc checkdb, would make your dbcc command take so much longer. It was a huge performance drain and a lot of complaints from us, from users and DBAs out in the community. So one of the changes they made is that it actually, now by default, CheckDB actually excludes those filtered columns and excludes those persisted computed columns unless you actually explicitly say that you want to check those as well. It will exclude those, which again increases even more your performance improvement or performance gain you're going to get. There's also spatial data improvements that they made. So previously when you would do anything with spatial data, during the execution you were kind of transitioning from unmanaged to managed to unmanaged within the code, so there was that handoff. The new change is they've actually invoked it as a native implementation now, so there is no handoff between unmanaged and then managed and then back again. Without that transition, there's an enormous improvement in performance there, because like with everything else, if you have the closest that you do any processing to the data that you're processing, the better the performance is going to be. So with the spatial data, now that you've eliminated the transitioning back and forth and back, that has improved performance immensely as well. TempDB configuration is another big one. That's actually been brought into the installer, so that you can actually, before it was just, TempDB was just created out there like another database, and it was one thing was set up, and that was it. Now, TempDB is brought into the installer, so it's actually a new tab in the SQL Server 2016 installer for you to actually configure right there during installation. So that's kind of one thing that goes into your installer and comes out of your, okay, fresh SQL Server installation checklist. I think we all have it, probably with a nicer name. than that, but we all have that file or that Excel spreadsheet of things to go through, or even that script that actually would alter those things after the fact. This now is rolled into it so that you can actually pick the number of files, initial file size. Just keep in mind that you want to turn on instant file initialization if you're going to go with a large tempdb files, or performance will suffer just like any other database. Now the one thing that I like to hear about is also with 2016, they're increasing the number of contiguous 8K pages. So previously, when you had your number of contiguous pages in previous versions was 32, now it's up to 128 contiguous 8K pages. This is going to help out with your bulk style operations like your select intos, anything where you're creating an index or even bulk inserts themselves. With the more pages, more 8K pages in groups or larger page groups, you're going to be able to, you're not going to have to pull pages off as often. That's going to improve performance as well. Now I don't have a quick poll to throw up, but I would imagine, normally if I was when I do this presentation in front of people, I would ask, all right, how many people have, see a lot of times in their wait stats the log writer, where they're waiting on writing to the log, but, usually in a high transactional environment. Now that was because you only had one log writer with SQL Server. 2016 introduces a total of 4 workers per instance. So now you've got 4 more workers writing to the log, so that you're not waiting on that log writer to come available for the next operation. Again, just additional little tweaks that they've made in the engine that are going to help you service your end users faster and have less performance problems that you have to diagnose later. And then also with another highlight I've seen from the engineering team themselves was the in-memory worker pool. So right now SQL Server with 2016, well anytime, SQL Server leverages a worker pool for the in-memory database, in-memory optimized database capabilities. So prior to 2016, the pool, to increase the size of the pool, you had to do a startup trace flag. So that was one more trace flag that you had to have on, in the service that actually started SQL Server. Now that's actually been removed. So that's one less knob you have to twist or turn to improve performance. SQL Server 2016 actually removed the trace flag and updated the design. So now the the in-memory worker pool is actually dynamically adjusted by the engine. So as it sees that it needs more workers, it'll spin up more workers and have them available. Or it'll spin down as needed as well. So you're seeing better utilization of resources going forward. Now, me personally, I'm a BI guy. Well, actually, before I continue on, a great post that I actually got a lot of this from to help me point him in the right direction. There's actually a blog post out there by Thomas LaRock. He's the former president, or the, President Emeritus of the PAS, which is Professional Association of SQL Server. He actually wrote a great blog post earlier this month about the new catchphrase for SQL Server 2016 from Microsoft is SQL Server 2016, it just runs faster. And what he actually did was compile a bunch of data between, let me see here. He compiled a bunch of data between the engineering team, which is where I've gotten some of this information from, the product support services team, and he actually, some slides that he got from the reviewers workshop that was on SQL Server 2016 probably about a month ago. He actually compiles a lot of that data. There's a lot of other things that I felt were getting into 300 and 400 and 500 level of internals that I felt was outside of the scope. But if you want to read more into that post, he's collected a lot of it, but again, the PSS team is going to have a lot more out there. You can actually get into what they have out there too by going to some of the articles he links to, and then just going back up a level to look at some more articles that they actually have as well. So actually Quentin has a question. 4 log writers mean that there can be up to 4 log files for each DB. No, it's still going to be the same number of log files, but previously with SQL Server there was only one service that actually was writing to the log. So there was only one log writer itself, whereas now there's actually 4 log writers per instance. Now, what I was going to continue on to is, you know, I started out as a BI guy and picked up DBA experience as needed. I think in a lot of ways, if you've ever worked in a small shop, that's how a lot of people in small shops learned how to be DBAs. Is they were basically handed the keys and said, okay, we're having this problem, you go fix it. So for me, I couldn't do this session without at least hitting on a few of the performance improvements that are coming to the BI space as well. So specifically, a lot of it is coming to the tabular engine. Now, fans of analysis services tabular have been disappointed since, you know, it first came out in, you know, a few years ago, is that it's been kind of ignored since it came out for any kind of improvements. When tabular first came out, one of the big complaints with it was, okay, you know, I don't have a lot of the same features as multidimensional. I don't have the ability to do many-to-many relationships, things like that. There's actually a decent amount of performance improvements specifically in the engine coming for tabular or that are out in tabular for 2016 that when looking at the improvements they've made, if you want to get into a 300-400 level, you can actually read some of the documentation and books online of the improvements they made, that I'd be hard-pressed to think of anyone who wouldn't see a performance improvement with 2016 analysis services. They've made a lot of changes in the engine specifically to help with direct query, so that direct query so that you can connect directly to the model and actually query against the database itself. Direct query is also used by Power BI. So a lot of the performance enhancements, again, fall in line in a lot of ways with that cloud-first mentality that Microsoft has right now. So again, the tabular enhancements, in essence, will help in the long run Power BI even be more performant as well. Also, you could not do parallel partition processing previously with the tabular model like you could with multidimensional. That, with 2016, is no longer a problem. With 2016, it introduces parallel partition processing for your cubes, which again is it's helping with your maintenance. So not necessarily end user performance, but definitely administrative performance of your cubes. And then again, I already talked about it, just the ability to create many-to-many relationships and that cross-filter is a huge win for the tabular model. Just going to check real quick, see if we have any more questions. Let's see. I think there was one more. Michelle, I hope the slides are changing for you now. Is anyone else having problems with the slides not changing?
No, you're good, Josh.
Okay, just making sure. All right, let me, there. Okay, so let's continue. So now the next thing we'll get into is we're going to get into some of the actual big name features, and some of them you might have already seen a webinar this week on about some of the larger features that more publicized that are going to help your performance. I'm going to do an overview of them just because we've had some great webinars this month, or there's other webinars to follow that are actually great webinars to actually go in depth on these features. But again, I kind of wanted to make sure for this session I do it for webinars here, but I also do it at SQL Saturdays. So this was more, this is definitely geared towards making sure that we give a full overview of performance improvements in 2016. So little quick info on what stretch database is, because some of you are probably sitting there going, well, stretch database, what is that? So what stretch database does is you actually set it up on a database and then configure a table to work with stretch, and it actually splits your data between your server and in Azure. So this is a great option if you have large tables with transactional data. So if your accounting system, your ERP system is on there, your transaction table for your accounting department, for your general ledger, that would be a great candidate for pushing some of it to Azure, especially if it's looking at part of the table is cold data, so very historical. Maybe it's got 15 years worth of data in it. Oh, I have another question. Kieran, actually the recording of the session will actually be out probably in the next couple of days. Liz is great about getting those out as quickly as possible. So once that's out, you'll be able to view it right on our website, pragmaticworks.com. With stretch database as well, it actually it's going to push that data. It's going to push the cold data, so the data that isn't accessed regularly, right out to Azure. And then when you query your table, it'll pull the data in from Azure as needed. Okay? So what this is going to do is, I would imagine there's plenty of us out there who have large storage sands out there to store all of these large amounts of data for transactional systems. Now this takes the stress off of the storage because you're storing a lot more off-premises, out in the cloud, out in Azure. So you're going to save on local storage costs there. You're not going to have to be purchasing as much storage to have connected to the server in one way, shape, or form for doing this. It's also going to shorten your backup window, because when you enable stretch database, that data that is in the table and stretched out to Azure, that's being backed up in Azure. That is not pulled back in to be part of your on-premises backups. That's always the tough one that I think a lot of people don't necessarily think about at the time, but that's actually, once it's stretched out to Azure, Azure maintains the backup of that data, and it's held out there and backed up and redundant, same as any other Azure SQL database, so that you don't have to worry about it. The other nice thing is it's a silent sync that is baked into the SQL Server engine. So this data is pushed out and synced out there is done behind the scenes. It's nothing you have to worry about. Now, a great question, and I was going to get to that actually, Maj, was can you stretch data onto another server? At this time, it is not available to stretch database onto other SQL servers. Do I see that there's an advantage there in some cases? Absolutely, where you could maybe stretch data into an Azure VM possibly even, but at this time stretch database only works stretching data to an Azure SQL database. Does Azure back up the entire table or just the portion? Joe, great question. So Azure backs up the entire copy of the table that is in Azure. It only backs up what data was stretched to Azure, not the entire table itself. So your backup would actually be, would contain any data that wasn't stretched via the engine. So maybe the current year's transactions, if you want to go with the transaction table. Then there's other, but the data that stays on site would be backed up by your internal process. Azure takes care of what's in Azure. What are some of the data types? Actually, I'm working on a blog post about that. Some of the data types that you can't do with Stretch that are out there, I don't have handy with me right this second the exact list, but I will keep that one to answer with you and get with you, Mark, afterwards. Is the data stretched to Azure available for read? Nitin, great question. So yes, it is. When it's stretched to Azure, it's there, and as far as anyone querying your SQL Server, it looks like the data is still living on your server. So if you were to query that transaction, that general ledger transaction table, it would actually go out to that table, and SQL Server says, oh, this is a stretched table. I need to go out and pull the records down that are in the stretch database and service those records as well. So the nice thing about Stretch is there's no need for any code changes. Stretch database is transparent to your end users. They're going to still write queries like they always have, but the data is going to be there. Another question, I've heard that while stretching the database, the constraints on a table don't work. Is that true? Yes, it is true. Also, the data that's stretched cannot be updated or changed. So in some cases, that creates issues. But again, this is designed more for not transactional data. This is designed to push out cold data out of your data center, data that is not being updated, data that is not even necessarily being read that often. It's there, like in some cases, I've referred to it, in certain situations with different customers as these are, this is your security blanket data. So maybe your audit says you only need 5 years worth of accounting data or sales data or something like that. This is your 8 years ago sales data. So this is a lot of the data that is there just in case, but is rarely used. Another great question. If you need to retrieve the data from Stretch database, do you need to do anything differently from the application side? No. There are no code changes required. There's some other features of SQL Server 2016 that do require code changes, like the always encrypted. Always encrypted requires code changes. Stretch database does not. It's transparent to your end users, transparent to your programmers, and how you query the database. It just takes care of it behind the scenes, like it says in the slide, a silent sync. It's also a silent acquisition for your users to query the data. So how do I rebuild my archive data from Azure if there are so many restrictions on losing a lot of metadata like foreign keys, constraints, and other features of data structure? So with the data and the restrictions around your constraints and things like that, if the constraints become a problem where if you're using GUIDs for a primary key or something like that, that data that's stretched out to Azure isn't necessarily going to, that constraint isn't going to be held. So it could create issues. But again, we're looking at data that's in a lot of cases cold data. It shouldn't have a lot of issues where you would worry about constraints and things like that, because it should be data that's not being changed a lot or anything like that. If I back up a stretched database via the SQL backup command and then restore the database on another server, what happens to the part that was stretched? Does it come over? I am not sure. I haven't tested that, and that's a great question. So thank you, Azar. You've given me a great blog to come out of this webinar for. These are the kind of questions that I haven't thought of that would make for great testing and blog posts. So Azar, I'm going to take that one offline, and I will test that actually this week and get a blog post out, and I will actually send you a link to it. Will there be any problems with performance with Stretch database? Now, Is there a performance impact? There is obviously there's going to be some latency to pulling the data from Azure, but that data that latency is very minimal, because when you're stretching data to Azure SQL database, the performance level of that database you're stretching to is a very high level. So in that case, you're not going to have like a lot of issues trying to get your data out. There will be some additional latency, but I wouldn't say there's a problem. With any of the work I've done and demos I've done for proof of concepts for customers using stretch database, the latency was minimal. So if anything, some queries that maybe took 30 seconds to run might take 32, I think was the one example, where it just added on a couple extra seconds. But again, this was retrieving an additional and pulling into the server to do aggregations on millions of records. So I mean, it wasn't a large performance impact at all. I wouldn't even call it a problem, but there is a performance impact, yes. When the data from Azure read, does that become hot and reside on premises? No. So when the data is read from the Azure SQL database, it's still on the Azure SQL database. It doesn't come down. The only time the data would come out of the Azure SQL database is when you would elect to turn off stretch on the table. Then a reverse sync operation goes into effect and actually starts pulling your data out of the Azure table and putting it back in the local table. Now, one thing I will tell you about that is if you decide to stretch a table and then decide, you know what, this table and stretching it out, this isn't everything I hoped it would be, or maybe I got more of a performance latency than I expected because, X reason, and I don't want to do stretch anymore. When you pull that down, when you turn off stretch, all that does is pull your data back into your database. Your Azure account will still have that Azure SQL database on it with your data in it, and you will still continue to be charged. That was actually one thing we found here at Pragmatic Works doing our own internal testing during the initial release candidates and things like that of Azure SQL databases, that the stretch database in Azure does not automatically remove when you turn off stretch, so you need to go out there and actually take that database down so that you don't continue to be charged. Is there a required minimum speed between my data center and Azure? No, there is not. But again, obviously the better the speed you have, the less the latency is going to be. If you're concerned about the speed between your data center and Azure, it would definitely be something I would want to look at and test thoroughly before rolling it out. Great question, Lisa. Thank you. Nitin, is there any difference in wait type for data fetching from local disk I/O and data being fetched from Azure? I don't believe it has its own wait type specifically for that, but honestly I'm not totally sure either. So Nitin, I'm going to save your question again for the post-webinar blog post. I like to do that after I do a webinar, especially one where there's a lot of good questions like today. I don't want to spend too much more time here. I did answer this question. Can you change the stretch table back to non-stretch down the road? Yes. Do indexes work on stretch data? Yes, they do. But the query operation to get the data still has to pull all the data matching your where predicate from let's put it this way. When you query the data and it comes in from the Azure SQL database, your where predicate is used against the data to filter the data on the Azure SQL database. Then it's brought down into TempDB and then combined with the data that's stored locally. So it could be a little hairy at that point. So you can actually pull down a lot more data than you might need in some cases as well. If the Azure server is down, your stretch database is, your stretch table is missing that any of that data that's stretched. Now, that also is can create an issue. If your Azure server is down, that I wouldn't necessarily worry about that as much because of the redundant systems. While it is a possibility, it's a very rare possibility. But yes, you just wouldn't be able to access that data in the Azure SQL database. So now this kind of goes into the process of when you would stretch it to the cloud, it would actually take that piece of order history, put it out in Azure, so that when you query it, your query goes to the local SQL server and the SQL server pulls from Azure. That's just a nice graphic to have in that. It's actually going to create a linked server connection in the stretch database architecture. So I know some people cringe at that, but in essence it's a secured linked server connection that the engine creates with its own password and all that for it to use for the queries. So now the pros, again, we talked about a lot of them. The decreased storage footprint, there's no code changes, no connection parameter changes. Data transfer is secure, it's actually an encrypted connection, and it will work with the always encrypted feature. But there's a caveat. If that always encrypted feature is enabled before you stretch the data. If you stretch the data and then try and do always encrypted, it will not work. Okay? You have to do it in that specific order. The cons, though, is it does, I mean, in a lot of cases, there are a lot of people, and me included, get kind of nervous when you talk about linked server connections. So I did put this, over in a con. Another con is the actual additional cost to store in Azure. So while yes, there is a savings for how much storage you have to have locally, there is that additional cost in Azure. It's not just free. It's not included with your license or anything like that. And again, when using with always encrypted, that has to be enabled. Always encrypted has to be enabled first because you can't alter the data once it's in the stretch. Minor additional latency for querying the cold data. Again, we talked about that already. There is a latency. Have to list it as a con because it's a negative, but it's not a very large and measurable con. Unique is not enforced on the Azure table itself, so you can't insert or update or delete rows in the stretch table. So if you're stretching transactions and transactions older than 5 years ago are stretched out there, you can't insert a new transaction or update or even delete any of them in the stretch table. If you want to do that, you have to actually turn off stretch, have all the data come down, do the operation, and then re-stretch it. Queries continue to work. Without any kind of code changes, we talked about that. That's why I just trying to jump through that. That came up in the questions already. Your advanced security features are supported. So data in motion with TLS 1.1 and 1.2. Always encrypted support if enabled by the user, and the data encryption key remains on premises. That's why always encrypted needs to be enabled before you stretch it, because the data will be encrypted in the table at rest and then pushed to Azure. And then the encryption key remains on premises so that when you query the data, that's when the data isn't decrypted until it's back in your SQL Server or back at the client with always encrypted. Row-level security is already working, and SQL Server and SQL Azure Audit is already working as well. Backup and restore benefits, we already talked about them. I'm not going to waste a lot of time on that, but again, you're going to shrink your database backup and restore window because you're not backing up or restoring as much data. I think we went through a lot of the questions. But again, keep firing them in if you've come up with more questions on stretch. At the end of this, Liz is wonderful, and she sends me a nice spreadsheet of all the questions that were asked during the webinar, and then I will actually go through them and answer the main subject questions. So there's usually a few people that ask a lot of the same questions, so I'll answer the general questions as much as I can. If I don't answer your question, on my blog post, feel free to reach out to me and in the blog post and comment on it, and call me on it if I don't get your question. Ooh, that was a roll. I didn't mean to roll my wheel. So in-memory is what we're going to talk about now, specifically in-memory OLTP. In-memory OLTP has made some definite advances in that previously, from when it was previously deployed. So a little quick info about it. It's a separate engine fully integrated with your standard SQL Server database engine, but it's optimized for OLTP workloads to be stored in memory. So what it is the data stored in memory, and changes to it are then synced back down to disk, so that if for whatever reason there's a power loss on the server, catastrophic failure in the memory, you have the most current version on disk. What SQL Server 2016 has done, though, is it's expanded a lot of the available T-SQL functions and ability to alter the memory optimized tables. So a lot of time before, there were a lot of alter table functions. We're doing index rebuilds and things like that. You couldn't necessarily do that. Also, the max memory for the table size has been increased up to 2 terabytes. That wasn't the case before. I think it was 250 gigs. So now with the additional OLTP enhancements, you get full schema change support. So you can do add, alter, drop columns or constraints, or add and drop indexes are supported as part of alter table, which you couldn't do before. You're able now with the T-SQL coverage has now expanded to include just about everything, including scalar user-defined functions. They've also improved the scaling of how these operations are done as well, so that they're more performant. And then you have some reports along, some improvements in the reports along migration and things like that, so that you can actually manage the in-memory tables better as well. So the alter syntax is used for making any kind of changes. This includes with an in-memory table, indexes are also considered part of the table definition. So now that was the aggravating part, is if you wanted to, you had to take the table out of in-memory OLTP to make any kind of index changes. Otherwise, they were basically stuck. Whereas now you can actually do those operations without, with that table still being memory optimized. You can also perform alter operations on natively compiled stored procedures using the alter procedure. That's kind of outside the scope of this, but again, that's another piece that's out there. So with the any of the in-memory stored procedures and SQL general T-SQL coverage, you're allowed to do a lot of the schema binding and begin atomic required for natively compiled stored procedures. You can do the grant and deny permissions with them in memory now as well. I'm not going to spend, again, a lot of time with that. I think we burned a lot of time with stretch as well, and I want to make sure we kind of get to everything. So they've also worked on the scaling so that it's been enhanced to scale linearly now on servers up to 4 sockets. So you have multiple threads for memory optimized tables. Also multi-thread recovery, and you can actually do merge operations. And then again, getting back to the DBCC CheckDB, it's now using in-memory for some of its operations, which has increased its performance 7-fold. So when you talk about in-memory OLTP, the next question from a lot of users is, what can it do for me? So why would I want to use in-memory OLTP? Well, some of the scenarios, these are a lot of the main popular scenarios for when you want to look at using in-memory OLTP. For instance, if you're having a high data insertion rate, so if you're a retailer, your SQL Server database is your sales database. So you're getting, or your inventory operations database. So it's getting a lot of transactions for creating records for inventory actions or creating records for sales. Primarily append only, and you're unable to keep up with the workload, so you're creating a lot of records, not a lot of updates, but you're falling behind. The benefits in this is a great option because, again, all the activities, all the data lives in memory, which means that the actions that you're trying to take to the data, any reading of the data, is a lot faster on RAM than it is pulling it off of disk. You're going to eliminate a lot of the contention issues because of that, because it's quicker to access, quicker to create the records. You're also going to reduce logging. If you're having any issues with read performance or scale, high performance read operations on an already highly taxed read system, again, a great example of that is usually retail sales or inventory systems, and you can't meet your scale-up requirements. Again, this is going to eliminate the contention. You're getting low latency data reads because you're reading from memory instead of disk, which is DBAs. We all know that's better. And faster execution time. If you're having an issue with complex business logic, so if you have large DML workloads, complex computations and stored procedures that are being done on tables, specific tables, putting those in memory, again, and you're already having contention issues, any kind of contention issues, I usually recommend to customers to at least look and see if in-memory OLTP is a possibility, just to get more out of your existing hardware. Anything where you're going to be reading a lot of data or computing a lot of data, in-memory OLTP can give you an advantage. Now, I've actually have experience working at software companies as well. I worked actually for a startup out of Jacksonville for a few years. One of the problems we had when I walked in the door is we were keeping session state in SQL Server. If anybody's done that, that can actually kill app performance. A lot of times session state's recommended to do in other ways. I've heard MongoDB, but another great option now with 2016 is to put session state in an in-memory optimized table. So creating your session state database and then putting the tables for that in memory. Because then again, any of the issues I've ever had with session state and SQL Server were obviously latency. So again, fast retrieval you'll get from putting it in memory, but also contention issues. I've had issues where there were deadlocks before in the session state database because we were trying to do too much. So we actually moved it off to Mongo before I left, putting session state in Mongo, which was a great, great fun project. But again, moving that session state into memory is perfect because those are your high transactional operations, lots of reads, and contention issues just come naturally by doing session state there. Now again, to keep moving, I'm recording your questions here in the webinar, and I will answer them if we have time at the end, or if we have time or in the blog post after the webinar. Okay, so now query store. So usually the question I get is people who understand what query store is, and if you don't, query store is a new addition to SQL Server in 2016 that basically stores all of your performance and execution plan information around the queries run on your system. So it allows you to look at historically and currently to peek at the execution plans that have ever been brought into SQL Server or have ever been created by the engine. So the nice thing is you can look at the history of query plans, you can look at the performance they've had, you can compare execution plans between different queries, and what it does is that you can then actually have the ability to force executions of specific plans. Now I could not find a big enough star picture to put on the slide next to that. And I couldn't find in time when I was getting this presentation around the meme of, if you're a comic book fan, of Peter Parker's Uncle Ben saying, with great power comes great responsibility. And I will use that line now. You have the ability to force executions or force specific query plans, for every time a specific query is executed. While you have that power, there's a great responsibility that comes with it, and I would only use it in very specific scenarios, because SQL Server will adjust the plan based off of, different statistics on the table, different things it sees with its own hardware, things like that. There's a lot of things in the algorithm that you don't necessarily take into effect. As those things change, if you force the execution of a specific plan, it will never recompile a new plan for that query unless you stop forcing that plan. So in essence, you could force yourself to continually use a plan that may down the road not be the best plan. Also, that execution plan could be great for reads, and that's why you used it, and that execution plan could impact other things down the road, could impact joins negatively, anything like that. So again, you want to be very specific and very particular about when you use that execution, because like I said, with great power comes great responsibility. Just because you can do it doesn't mean you should. That is actually another great line from Bradley Ball, if you've ever seen his on performance tuning. His session on performance tuning, he even tells you, you can add, I can't even remember, I think it's like 1,000 indexes to a table. Just because you can doesn't mean you should. But again, it gives the ability for DBAs to manipulate query execution like you haven't been able to before, but it also gives you a peek under the covers like you haven't been able to before. So when I told you about the query store, we talked about, it stores the plans, but it also stores metrics about how they operated. So you have two different stores within the query store. You have the plan store, where it actually tells for these queries run, these are the different execution plans that have been used ever. And then the runtime store actually will keep a history of metrics around those execution plans and different executions of those plans. So it'll store information like the history of the execution plans, or query plans like we talked about, the number of plan executions per plan, top queries that are killing you, or just queries in general, the resource usage patterns for a database. So is a database heavy on RAM? Is it heavy on processor usage? What? But also then the metadata about the plans. So when you look at the plans and number of logical reads at each step, number of physical reads, that sort of thing. Anything stored in a query plan is going to be in the query store. So you're wondering, why would I use it? It's going to give you the ability to track your query's performance historically. So not just looking at how's it running the last couple of times with the current plan that's in the cache, but how it's ran since I turned on Query Store. You're also, again, you're going to be able to have the ability to manipulate how it executes queries by forcing plans and fix issues with bad query plans. But again, with great power comes great responsibility. I've even told customers that if you're going to consider forcing a query plan, to set a meeting reminder for next month to evaluate how the query is executing. Has execution gotten worse? And revisit it and keep it as a recurring meeting, so that you can go back and revisit it and not set it and forget it. With Query Store, it's very easy to set something like that and forget about it and move on. The larger advanced workloads that don't change are great candidates for forcing query plans. So for instance, I worked with one system where we were, before we moved to Solar, which is an open source word cloud, or it's used for search engines and things, we were storing individual words from text documents in a table where we were actually manipulating our own query plans. Those are one of the few cases when I would consider using forcing query plans through the Query Store. But again, I'd be very hesitant and make sure you have some kind of reminder to remind you to revisit that. Do plans flush from the query store when SQL Server is stopped and restarted? No. This data is persistent. It's a regular database, regular set of database tables. So when you have problems with, a lot of the problems that it helps you with query performance, regressing is difficult. This is the void that Query Store does fill. It helps you detect long-term issues as well. So issues that have crept up on you, you can actually see them and how they've crept up on you, and even look at sometimes how the query plan changed that it affected, has become such a problem. So what it does under the covers is it's actually collecting the query texts along with all the relevant properties, all the plan choices as they change, and even all the plan choices that weren't necessarily picked. So if you run a query against SQL Server and it develops 3 plans and says, you know what, this one's the best, it'll give you all 3. And along with the performance metrics of any of them that were run, it works, and right here's the answer to your question, it works across restarts, upgrades, recompiles, any of that. Because what it does is when you send the query in, it gets compiled, the compile message and all that information goes to the plan store, then it goes to the next step of executing your query. That information then gets saved, the execution information in runtime stats, and then it's all stored into the query store schema. Okay? All behind the scenes, not affecting your workload. Not in a major measurable way. So again, your query text in context settings, in the query, go into the query, and then there's the plan, and then the runtime stats. This is the schema of that explained. So 1 row per query text per plan, and then 1 row per plan for each query. And then 1 row per plan per time interval. Okay? All stored within a table, regular database table. And then you can get the actual views here, and I will make this presentation available afterwards that you can get into, have these views and things like that. Okay? Now what it also gives you the opportunity to do is to monitor performance. So as you can see here, this is just an example report run against the query store of top 25 resource consumers for this specific database. So you can actually see which plans, it'll give you a plan ID for this specific query, its cost, and then the different query plans that were used during its execution, and which ones, you can then click on a couple and compare the plans and be able to look at which one is best for you. A great question that was actually just asked, and I want to answer it now because I know I don't have it in the slides, and it's a very good question, is the query store has to be turned on for a database, which is correct. Is there any downside to turning it on? Downside that would come into play is storage would be the first one I would think of, because you're storing more data. You're storing this data, all these metrics about the queries. How much space does it take up in the database depends on how much activity, how many queries are going against your database. So again, the downside and how much space are proportionate to how much activity you have on the database. Is it a certain age of the database in question? Percent age. I'm not sure what you mean, but I think if you're referring to how much history it keeps, that is all configurable within the query store setup, so that you can configure how much history it keeps. I mean, it's the downside of query store is going to be similar to change data capture in BI. So used mainly for BI, but it's inserts for each and every query that's executed. So you're going to be keeping metrics for each each plan that's created for each query ever kept or ever ran against your server, and then all of the metrics along with it, it can get pretty hectic, you know, and spiral out of control fairly quickly if you're, you know, looking at enabling it on a database, on all tables in a database, or on a database that is rather active. SQL Server 2016 actually includes Query Store. It's not an additional pay-for feature. It's included with the standard license. So, I mean, yay, thumbs up for Query Store, and for all of us that they didn't make it a bad, you know, or make it an enterprise-only feature. It is available in standard. So with that, I thank you again as we have a couple minutes left for a couple questions, and I'm going to mine some here out of the questions list. But I wanted to, before we run out of time, definitely say thank you to everyone for attending today. And again, if you have any questions, my email address is right here. You can also connect with me on Twitter. And also my blog is mytwitterhandle.com. That's all it is. Very simple. I tried to align everything. I figured my name is hard enough to spell. You might as well, if I'm going to use that as my Twitter handle and everything else, I might as well use it everywhere. So I'm just going through here. Heather, the System Health Extended event, I will connect with you offline about that. That's a good one. I don't know that there is any changes, but I want to double check before I say no, there isn't. So I don't want to give you misinformation. But I will connect with you after the webinar. Oh, Sean has a great comment. Josh is my hero, as it should be. I should be everybody's hero. Just kidding. Another question, kind of going back to stretch, because I know this was a big thing, was how is it decided which data is stretched to Azure? That's done automatically, how I like to call it. It's done dynamically by SQL Server based off of how often certain points of data are accessed. So again, the cold data that isn't accessed very often will get stretched. If the table itself is cold, I've seen it in demos where it actually stretches the entire table. So it depends. Let's see here. Let's get into something other than stretch. Is it cumulative size for all tables configured for in-memory optimized table? Yes. So with in-memory OLTP, it's a cumulative of 2 terabytes of data that is allowed to be stored in in-memory tables. So again, that may limit some from being out there. That also means you need to be very cognizant of how much data you're actually trying to put in memory. All right, if I didn't get a chance to answer your question, I apologize. I will be posting a blog post answering the questions, and I will get with Liz when that blog post is complete so that we can actually share it on the Pragmatic Works blog as well. Yep. So again, thank you everyone for your time. Liz, thank you as well for setting this up, and everyone have a great day.
Thanks, everybody. And like Josh said, you'll receive an email tomorrow with a link to the recording if you need it. And if you think of any questions, you can email me, Liz, and I'll forward them on to Josh. Thanks, everybody.